All right. So I was saying when you expose any substance here on Earth to heat, when you expose it to heat, it will either expand or contract depending on that material. Okay, so this was just an example given here of a rod which was exposed to heat as usual. Yeah, it was exposed to heat and it expanded from the normal length, which is L naught, to the new length, which is L. Yeah, so this is what happened here. So the connection between the L naught and the L is simply just the change in, simply just this part here. So in other words, you can write this as L minus L naught is equal to the change in L. Let me just write it properly. So this one, when you make the change in L as the subject, you have something like this. The change in L is equal to L, which is the final L, minus the initial L, which is L naught. So this is also very important when it comes to calculations. You have to know this. Okay, so let's move on. So we'll first start by looking at linear expansion. From linear expansion, we'll look at the expansion. We'll look at area expansion. And then from there, we're going to look at volumetric expansion or volume expansion. Yeah, so for linear expansion, we know to say this is just the expansion of any length, in short, any length, yeah. So, and this is usually represented by this formula here. Yeah, so I'm going to share this slide at your own time. You can go through these notes. Yeah, so let me just go through the last part, which says, for the same temperature increase, a 4 millimeter long iron rod will increase in length twice as much as a 2 millimeter long iron rod. We can write this proportionality as this equation here. Yeah, so this is very important. This one you just have to master it. Oh, for you guys, they give you formulas, but sometimes they might forget to give you, like what happened in your previous exam. It's not all the formulas that were given. Some of the formulas that were given there were wrong. So it's very much important for you guys to also know this formula. You know the formulas by heart. Yeah. So this is very much important. You have to know it. So we know that this part is just the change in length, which we can write as, so the change in length, we know that we can write it as L minus L naught. Yeah, L minus L naught, which is the final length minus the initial length. So we can put this there. And then this part here, L naught, is the initial length. And then this alpha there is the linear expansion, the coefficient of linear expansion. And then this delta T there is just the change in temperature. And of course, this temperature should be in Kelvin, should be the absolute temperature. Yeah. So if you've been given in a question the temperatures in degrees or in degrees Fahrenheit, you have to convert them to Kelvin before you can use this formula here. So now let's try to take, for instance, if you have the change in length here, the change in length which is given by L minus L naught, then this is equal to, you have the linear expansion, coefficient of linear expansion there, then you have L naught there, and then the delta T there. Then you have this as your equation. So let us now try to make L naught the subject. Let's see what will happen. So when we make L naught the subject, it means that this will go this side. Then you're going to have L, or let's try to make L, sorry, the subject. You're going to have L is equal to, you have L naught, then plus alpha L naught delta T. So this can be factorized to L naught, open brackets, you have 1 plus alpha delta t. So this is also very important, this equation here. It's also very important when it comes to calculations. Okay, so in this slide, I didn't put a lot of calculations. We're going to do a lot of calculations at the end of the whole topic, thermodynamics. I want everything to be, I want us to know everything. And then at the end of everything, come and start combining the concepts that we're going to learn to solve questions. Yeah. Okay. So let's proceed. Okay. Yeah, so let's proceed. Okay, so this is what I was just talking about. So the alpha there is just the coefficient of linear expansion, and then the units for the coefficient of linear expansion are per degree Celsius. So in other books they write it as degrees Celsius to the power -1. So in other books, they write it as degrees Celsius to the power -1. And then some books, they just say per, they just write it as per degrees Celsius. That's the same. Okay, so L, when you take L to be L naught plus that, then we replace, we make delta L the subject. That's what I was just solving there. Yeah, so this is, we derived this together. It's also very much important. You have to master it. So I'm going to send the slide in the group. So where L naught is just the length initially at the temperature T naught, and L is the length after heating or cooling to a temperature T. So if the temperature change, this one, if the temperature change delta T is equal to T minus T naught is negative, then the change in the length will be L minus that. The change in length, this will also be negative. So in case you've been asked to find the change in length, then you find the change in length is negative. It means that the temperature will also be negative if you have been asked to find the temperature as well. Okay. So this is just a table, a very important table that is that is very important when solving questions. So you don't need to master anything on this table. If there's a question that has been asked in the exam or in the test, you always have to be given this table, or they'll pick one of the values here. So this table just consists of alpha and beta. So beta is just the volume expansion, the coefficient of volume expansion. Alpha, we said, is the the coefficient of linear expansion, that's alpha. And then beta is the coefficient of volume expansion. And then there's also gamma, which is, beta is the coefficient of area expansion. And then gamma should be volume. Let's check. Okay, before we even, yeah, so gamma is the one that deals with area, sorry. And then beta is the one that deals with volume. So, okay. So alpha is the coefficient of linear expansion, and then beta is the coefficient of volume expansion. And then gamma is the coefficient of area expansion. So the relationship between alpha and beta is just alpha is equal to 3 beta. So you need to master this as well. So you might be given a question that is asking you to find or that is involving the change in volume, because you know that the change in volume is just equal to the same equation that we had, V, the same equation that we had was V, and then instead of alpha, let me just write it in this one. So the change in volume is equal to, instead of alpha there you have beta, and then you have V, and then the change in temperature there. So this is just in terms of volume. So in terms of volume, you just change the parameters. While there was L, you just put V, and then while there was alpha, you put beta for volume expansion. And then from there, the other thing that you need to know is that this beta will never be given in a question. They'll always give you alpha, expecting you to know that alpha is equal to 3. Oh, sorry, they're expecting you to know, they'll always give you alpha. So they assume that you know to say, this beta is equal to 3 alpha, not alpha is equal to 3 beta. So beta is equal to 3 alpha. And then for gamma, if for instance you're dealing with area, so gamma is equal to 2 alpha. Yeah, so you need to know these two equations. They are very important. So they always give you alpha, which is here. They'll just pick any metal from here if you have a question, or if they've given you a question involving a metal which is on this table. So they will pick any metal from there, and then they will not give you beta, they will not give you gamma. Depending with what you've been asked to find, you have to use any of these two equations. So you need to know them. Yes, Glory. Have a question?
Yes. So there will never be a case where the entire table is given.
No, yeah, they can give you, but it's not necessary. Maybe, okay, imagine the whole paper, maybe there's just one question which has aluminium. Is it, or how, or why can they give you the whole table instead of just getting the value for aluminium and putting it in the question? So it's not always that they'll give you the whole table, they'll just give you the value for that particular metal which is in the question. Okay, so let's look at this equation, this question here. Still, the steel bed of a suspension bridge is 200 meters long at 20 degrees. If the extremes of the temperature to which it might be exposed are -30 and +30 degrees, +40 degrees, how much will it contract or expand and expand? So the most important thing here, you first have to assume that this bridge is expanding linearly, or it's undergoing linear expansion. That's an assumption you first have to make. Then after doing that, that's when you'll be able to find, all right, so that's how you do it. Sorry, I was just trying to tell the guy who was playing music. Okay, so they are saying if the extreme of the temperature to which it might be exposed are 30 and -30 and 40, how much will it contract and expand? So they are saying and, not or. So that means that we have to calculate for both cases, expansion and contraction. Okay, so we first start by, we know that the initial temperature there was what? Was 20, and then the final temperature is 40 degrees. So we know that our formula is the change in L. The change in L is equal to alpha, then alpha L. We have alpha L naught, change in temperature. So the change in temperature is simply just equal to, so we can find the change in temperature by saying 40 minus what? Minus 20. That's the change in temperature. Then alpha, you get it from the table. We've been told to say the bridge is made of steel. So meaning you go to the table, you get the value of alpha. And then L naught has also been given. So the question is, how much will it contract? So L naught has also been given. Then, so we know to say this side we have, what is the change in L? We have L minus L naught, and then this is equal to alpha L naught, the change in T. So here is just a matter of replacing the values. We've been given L naught, we've been given alpha, which you can just get from the table. Yeah, even there L naught is there. Then the change in temperature, I just subtract 40 minus 20, which gives you 20. So you replace it there. Remember what I said, here you use the absolute temperature. You don't use the temperatures that we've been given here. But the reason why we're using the temperatures in the question, it's simply because if you remember very well, there was a point which I made. I said the change in temperature, the change in temperature when you're dealing with absolute temperatures is just equal to the change in temperature when you're dealing with temperatures in degrees Celsius. That's the reason why I've just gotten the temperatures directly. But if you are dealing, with temperatures, if for instance, okay, we'll look at the ideal gas law in the next session that we're going to have next week. That's when I'll explain this point properly. Okay. All right, so from there, I was saying you just have to replace the figures there and then make L the subject of the formula. Yeah, so this is what I was talking about. The first thing that you do, you make an assumption that this bridge was undergoing linear expansion. Then from there, you know that the change in L is given by that. Then you find the delta L there. So this is your delta L, which is 4.8 times 10 to the power negative 2. Then from there, you also do the same for negative 30. And of course, the change in temperature for this second part will be negative 50, because you know that the initial temperature is, to be negative 50, because it's going to be, this will be negative 30. Sorry, let me just write it properly. So this will be negative 30, which is the final temperature, and then minus the initial temperature, which is 20. And then this will give you negative 50. Yeah. That is the change in temperature. Then you replace it in the same equation, replace it there. Then you also replace L naught there and alpha. So this alpha has just been gotten from the table that I showed you. Then you find the change in length there. Okay. So let's look at the area expansion. The area expansion, like I said, is just the same formula, except that you just change where there is alpha, you put gamma, and then where there is L, you'll be putting area there. Yeah, so, and this point I already explained it. We said gamma is just equal to 2 alpha. Yeah, same applies to the change in volume. The change in volume, instead of using gamma there, we use beta. So beta is equal to 3 alpha. And then this gamma is known as the coefficient of area expansion. So we're going to look at questions about these the day we're going to have a tutorial immediately after thermodynamics. So what we're going to be doing is that every after a topic, we'll go through the tutorial sheet. Every after a topic, we'll go through a tutorial sheet. Every after a topic, we'll solve the tutorial sheet questions. Okay, let's look at the volume expansion. So the volume expansion is just the same formula, but to just be changing where there's alpha, you put beta, and then where there is L, you put V. So for the area, for the linear expansion, we had delta L being equal to alpha L change in temperature. So for volume, we're just going to say the change in volume is equal to beta there, and then you have V there, then the change in temperature. Yeah, so let me just write it properly. Yeah, so the change in volume is just given by a beta there, then you have V there, then change in temperature. And of course, we said beta is given by 3 alpha. Yeah, so this is how you deal with volume. Okay, so let's see. Yes, so yeah, and of course you need to know that the volume that you are using there, the area that you are using there, and the length that you are using there is simply supposed to be the initial length, initial volume, and initial area. And this part should consist of absolute temperatures. Okay. And then this B, simply just the coefficient of volume expansion. And then B, so starting from alpha, gamma, and beta, all these have the same unit. The unit is per degrees Celsius. You can say per degrees Celsius, or if you want, you can write it as degrees Celsius to the power -1. It's just the same. So these are the units for these, for alpha, gamma, and beta. Okay. So what we have just discussed is very important. So we're going to apply them in the questions in the tutorial that we're going to have. And the next topic I think that we're going to do, the next topic that we're going to do, we're going to start ideal gas laws. And then after ideal gas laws, we're going to do the laws of thermodynamics. Then we're done with thermodynamics. Yeah, so it's quite a long topic, but very simple to understand. So we're done with linear expansion, area expansion, and volume expansion. So the next time we meet, we just do ideal gas laws. And then from ideal gas laws, we'll go to laws of thermodynamics. From there, then we'll go to the next topic in physics. Yeah, so thank you very much for attending today's lesson. I don't know if you have questions from what we have learned. And I think I may also send an exercise on what we have learned, just to keep you busy and to keep your mind busy, and for you to just at least have a concept on what you have learned. Because just watching what I was explaining here is not enough for you to know that you have understood. Yeah, so the next topic, we're going to look at the ideal gas law and the kinetic theory of gases. Then from there, we'll look at the laws of thermodynamics. All right, so do we have questions? Okay, so for those that attended yesterday's lecture, even those that did not attend, make sure that you submit your work for mathematics tonight. I want tomorrow morning, I think I'll send a link where I'm going to explain the exercise. So meaning for those that had challenges when solving the exercise, I'm sure that's why you get the concept properly. Yeah, I'll take time to explain the exercise. But for those that have not yet submitted, quite all right. I've seen a lot of people have done it well. Yeah, at least the performance is okay. So I'm glad to know that you're understanding what I was teaching. I mean, what I'm teaching. Okay, so I need to see, even for those that have not yet submitted, whether of course, I just submit. Let me just know at least where you have a problem, so that even the time I'll be explaining, I'll make sure that on that part I'll emphasize and I'll talk about it. Apart from that, I'm also explaining just right there on WhatsApp. I'm explaining when you give me a wrong answer, I'll circle it. I'll circle it, and then I'll circle the part where you're wrong, and then I'll explain why you are wrong and how to do it. Yeah, so make sure that you submit tonight. I'm not sleeping this time. I'm sleeping somewhere around 02 or 03, so you can submit anytime before 03. I'll attend to you. Thank you very much for attending today's lecture. See you tomorrow in mathematics. So in mathematics tomorrow we're doing hyperbola and the parabola. Then we're done with analytical geometry. So see you tomorrow in mathematics.